This is a very interesting question. A block of weight W starts from the rest and slides in a vertical plane along a arc AB on a smooth cylinder of radius r. At point B, it leaves the cylinder and travels along the dotted path BD. Find the distance small b, defining the position of the point D from the point C at which the block strikes the horizontal plane. So first of all, we are going to draw the figure. So figure that is given in the question is that there is a cylinder of radius r and this is the center O. This is the initial position of the block. Let us suppose it is called as A, and this is the position of the block B. From this position B, it launches something like this and strikes the plane at point D, and let us call this as C. So this is the B distance which is given, and this will be the velocity. So this is the figure given in the question. So we are going to find out this distance B, that is CD. In this case, let us draw this figure in the enlarged version. So in the enlarged version, we can draw it like this, and let this point be O. This will be point A, and this will be point B, and here there is a object, and is this object there is a force that is the normal which is acting in outward direction, and let us call this angle theta, and there is a force mg which will be acting in downward direction. So this angle will be also theta. Now this mg is going to have two components. One will be in this direction. This will be mg sine theta. Write it there. This will be cos theta because of this angle theta. Another one will be in this direction. This will be mg sine theta. Now based on this, we can find out the forces acting on the block at point B. So this is position B. So we can write forces acting on the block at point B. Let us call that force Fc. So which will be equal to mg cos theta minus n, and which will be equal to mv square upon r. Let this be equation 1. Now we are going to use the law of conservation of energy. So we can say that by law of conservation of energy between point A and B. So we can say that mgr plus 0 will be equal to mg cos of theta multiplied by r plus half mv square. So from this we can write it as 2 mgr is equal to 2 mg cos of theta multiplied by r plus mv square. So if we make this into left side and take 2mg as a constant, sorry, outside the bracket, so we can say 2mg, and rather 2mg r 1 minus cos theta is equal to mv square. Let me call this as equation 2. So from equation 1 and equation 2, from equation 1 and 2, we can say that mg cos theta minus n will be equal to 2 mgr 1 minus cos theta divided by r. What we did, we simply substituted value of mv square in equation number 1. So we get this part. So here r cancels out with r. So we get this as mg cos theta minus n is equal to 2 mg 1 minus cos theta. Let us call this as equation number 3. Now we are going to redraw this figure again, but now only with respect to breaking point B. So let us draw it again in a bigger fashion. So we have, this is point C, center O, this is point A, and this is our point B. So let us draw this is the horizontal line which is parallel to this part, and it will be launching, let us suppose, at an angle at a velocity of v0. This angle, let us suppose now this angle is theta naught, and this angle is also theta naught. This will be radius, and let us draw a parallel line to here part. Let us call this point as, one second, this point is D, and let's call this point as E. So this distance will be x0, and this will be B, and this total distance, let us call this as y0 up till this point from this. Okay, so if this is x0, and then this distance will be also x0. So this is the basic figure. Now this point B, we are going to call this a breaking point. At this point, the object leaves this right circular, this cylinder. So you can say that at breaking point B, the normal will be equal to 0, and let theta is equal to theta naught. So we are going to modify equation number 3. We are going to add normal is equal to 0 in the equation number 3. Theta will be equal to theta naught. So then equation 3 becomes, so equation 3 will be coming as now mg cos theta naught minus 0 is equal to twice mg 1 minus cos of theta naught. So we can write this as mg cos theta naught is equal to twice mg 1 minus cos theta naught. Now we open the bracket. We get this as twice mg minus twice mg cos of theta naught. This is equal to mg cos of theta naught. So bringing this to left side, we are going to get mg cos of theta naught plus twice mg cos of theta naught is equal to 2mg. So this will be coming as 3mg cos of theta naught is equal to 2mg. mg cancel out with mg and we get cos of theta naught is equal to 2/3. Now we already shown that in the figure the projectile is launched with the velocity of v naught, making angle of theta naught. So we can say that if v naught is the velocity acquired at the breakoff point, then mg cos of theta naught will be equal to m v naught square divided by r. So here m cancel out with m and cos of theta naught is given as 2/3. We substitute here, so we get g 2/3 is equal to v naught square divided by r. So from here we find out v naught. So v naught square will be equal to 2/3 rg, or we can write that v naught is equal to square root of 2/3 r multiplied by g. Next, now what happens after the breakoff point? It is going to act as a projectile. So we can write it as after breakoff, the block becomes a projectile, or acts like a projectile, becomes a projectile whose velocity is given as v naught and angle of projection, or angle with the horizontal and angle with horizontal is given as theta naught. Now we are going to use the equation of kinematics to find out what will be the horizontal distance traveled as well as what will be the vertical. So we can write it that vertical distance of the breaking point, vertical distance of the breaking point B above the ground, So we have already denoted this distance as y naught. So this is point B. So this distance point B is at a vertical distance or vertical height of y naught. So we can say that y naught is equal to r plus r cos of theta naught. So we can say that this is nothing but radius r, and this is theta naught, this is r. So we can find out this will be equal to r cos of theta naught, and we already know value of theta naught. We can write it here, r plus r divided by multiplied by 2/3. This will be coming as 5/3 r. We can say that y naught is equal to 5/3 r. Similarly, we are going to find out the horizontal distance. Horizontal distance, which will be nothing but x naught, which means the horizontal velocity r sine of theta naught into and r sine of theta naught. Sine of theta naught we can already find out from cos of theta naught, so we can write this as 1 minus cos square theta naught. So x naught will be equal to r 1 minus cos of theta naught is 2 by 3, so this will be coming as 4 by 9, its square root. This will be equal to 5r divided by 3. So we can say that x naught is equal to square root of 5 multiplied by r divided by 3. Now we solve it for the motion in y direction. Motion in y direction. So initial velocity in y direction will be equal to v naught sine of theta naught, and acceleration of will be equal to g. So we can say that s of y is equal to uy t plus half ay t square, and the motion in y direction, that s of y, that is vertical distance, is already s of y will be equal to y naught, which we have calculated as 5 by 3 times r. So we substitute it here, so we get 5 by 3 times r. U of y is v naught sine of theta naught multiplied by t plus half g t square. Let us call this as equation number 4. Now we are going to do the motion in y direction, sorry, x direction now. So motion in x direction. So initial velocity in x direction is equal to v naught cos of theta naught, and distance in x direction is given as b minus x naught. So we can say that distance in x direction is equal to ux multiplied by t. So we already know this is b minus x naught. Ux is given as v naught cos of theta naught into t, and let us suppose that let b minus x naught is some variable c. So we can write this as c is equal to v naught cos of theta naught into t. So from here we find out value of t. So t is equal to c divided by v naught cos of theta naught. This equation is 5. So we have again going to write equation number 4. So equation number 4 was given as 5 by 3 r is equal to v naught sine theta naught into t plus half g t square. In this equation we are going to substitute the value of t. So we got this as v naught sine of theta naught into c divided by v naught cos of theta naught plus half g c v naught cos of theta naught and its whole square. Here v naught cancel out with v naught, so this will be equal to c tangent of theta naught plus half g c square v naught square cos square theta naught. So this is equal to 5 by 3 r. So we already know cos of theta naught. So we can say that cos of square theta naught is equal to 4 by 9. From here we can find out what will be our tan of theta naught, which will be equal to square root 5 divided by 2, and v naught we already found out, which was equal to v naught is equal to 2 by 3 gr and its square root. We are going to use these values and substitute here. We get 5 upon 3 r is equal to c tangent of theta is 5 by 2 square root of 5 divided by 2 plus half g c square, and we have v naught square, so it means it will be 2 by 3 gr and its square root and its square, and cos will be equal to cos square is given by 4 by 9. We are going to solve this further. This will be equal to 5 by 3 r is equal to c multiplied by square root of 5 divided by 2 plus half g c square divided by 2 by 3 gr multiplied by 4 by 9. So g cancel out with this g, and this will be coming as a quadratic in C. So we can write this as 81 c square plus 24 square root of 5 r multiplied by c minus 80 r square is equal to 0. So we can say now we are going to find out the roots of c. So c will be equal to minus b, that is 24 5 r plus minus square root of b square minus 4 AC, that minus minus will be plus 4 a is 81 and c is 80 r square divided by 2 into 81. So take considering only the positive value of c, only considering positive value of c. So we get c is equal to 2880 r square plus 25920 r square square root minus 24 5 into r divided by 162. So the final solution of c will be coming as 20 root 2 minus 4 root 5 divided by 27 multiplied by r. And we know that b minus x naught was equal to c, or we simply can say that b will be equal to c plus x naught. So substituting value of c, we get 20 root 2 minus 4 root 5 divided by 27 plus x naught we already know, sorry, multiply by r also, and x naught we only know is given by square root of 5 divided by 3 r. So finally b will be coming as 1.46 times r. This was the required thing. which we are supposed to find out. We were supposed to find out what will be the distance between point C and D, that was B. Thank you.